The Earth trembled. 300 million years ago, the planet was a stage for a collision of titans. The ancient landmasses of Gondwana and Laurasia, vast and unyielding, crept toward one another with the inevitability of destiny. The crust groaned under the strain, buckling like warped armor as the continents crashed together in a slow, cataclysmic embrace. Mountains erupted from the violence of the impact, their peaks clawing at the sky. The Appalachians and the Varascan ranges rose like jagged scars forged in the furnace of tectonic fury. Molten rock surged beneath the surface, hissing through fissures and erupting in great gouts of lava that painted the land in fire. The air itself shimmered with heat, thick with ash and the scent of scorched stone. Rivers of magma carved new paths through the wounded earth, their glow illuminating the chaos. The land heaved and split, reshaping itself in a spectacle of raw power. Where once there had been separate continents, now there was only unity. Pangaea, the all-earth, a singular supercontinent stretching from pole to pole. The oceans, too, bore witness to the transformation. The vast Pangaea, the global sea, swallowed the remnants of smaller oceans as the land masses merged. Coastlines vanished, swallowed by the shifting crust, while new inland seas formed in the valleys between rising highlands. Life, scattered and diverse, now found itself bound within a single colossal cradle. The ancestors of reptiles and amphibians scurried through the upheaval, their world remade in fire and stone. The stage was set, a new era of evolution, of giants and survivors, of a planet united under one unbroken land. And so Pangaea was born, not in quiet whispers but in the thunderous roar of a world reshaping itself. The supercontinent stood as a monument to Earth's relentless power, a fleeting empire of stone and sky that would one day fracture, but for now ruled supreme. The dust settled. The violence of Pangaea's birth gave way to an era of unparalleled abundance. Sunlight spilled over the supercontinent's sprawling landscapes, painting the world in gold and green. Towering mountain ranges, their peaks still sharp from their violent ascent, cast long shadows over valleys thick with ferns and cycads. Rivers, fed by seasonal rains, carved serpentine paths through the land, their waters teeming with ancient fish and amphibians. To the north and south, vast deserts stretched like oceans of sand, their dunes shifting under the relentless wind. Yet even here, life clung tenaciously. Scorpions and hardy reptiles burrowed into the cool depths, emerging only under the cloak of night. Along the coasts where Pangaea met the endless blue of Pangaea, tidal pools brimmed with creatures both strange and familiar. Trilobites scuttled through the shallows, their armored bodies glinting in the sun, while early sharks patrolled the deeper waters, silent and sleek. Inland, dense forests of towering conifers and ginkgos formed a verdant labyrinth. The air hummed with the drone of giant dragonflies, their wingspan stretching wider than a man's hand. Beneath the canopy, the first reptiles, small, quick, and cunning, darted between the undergrowth, their eyes sharp for prey. Some scurried up trees, their claws finding purchase in the rough bark, while others basked on sun-warmed rocks, their scales drinking in the heat. The heart of Pangaea pulsed with life. Great floodplains, nourished by seasonal monsoons, became nurseries for countless species. Here the first ancestors of dinosaurs, lithe and bipedal, prowled the fringes of murky swamps, their calls echoing across the water. Amphibians, slick-skinned and vigilant, lurked in the reeds, their jaws snapping at unsuspecting insects. It was a world of extremes, of blazing deserts and mist-cloaked jungles, of wind-swept highlands and tranquil lagoons. Yet for all its diversity, Pangaea was bound together, a single, interconnected web of life. Creatures could traverse the supercontinent unimpeded, their migrations shaping evolution in ways never before possible. The Golden Age had begun, and in its warmth, the The first whispers of a dynasty yet to come stirred tiny sharp-toothed reptiles, their descendants destined to rule the earth. The reign of the reptiles had begun. Across Pangaea's vast expanse, early archosaurs, the ancestors of dinosaurs, emerged as the dominant predators. Their lithe forms darted through the undergrowth, their sharp claws and keen eyesight making them unmatched hunters. Among them, the first true dinosaurs, small but fierce, began their ascent. Euraptor and Herrerasaurus prowled the riverbanks, their serrated teeth glinting as they tore into prey. The supercontinent's unity was their greatest advantage. With no oceans to bar their way, species spread unchecked, adapting to deserts, forests, and floodplains alike. A colophysis hatched in the shadow of the Appalachians could in time find itself stalking the scrublands of what would one day become Argentina. Genetic diversity flourished as isolated populations mingled and evolved under Pangaea's boundless skies. In the north, where seasonal rains turned arid plains into temporary wetlands, armored reptiles like Scutosaurus lumbered through the mud, their thick hides warding off attacks. Meanwhile, in the humid south, sleek Proterosuchids lurked at the water's edge, their crocodile-like bodies perfect for ambushing unwary amphibians. But it was the dinosaurs who were poised for greatness. Unlike their bulkier relatives, they were built for speed and endurance. Their upright posture allowed for efficient movement, their lungs drew breath with unmatched efficiency, and their metabolisms hummed with energy. When the dry seasons came, and lesser creatures faltered, the dinosaurs endured. Pangaea's mountains became corridors, its deserts mere obstacles. A single species could conquer a continent, and as the ages passed, these pioneers grew larger, bolder, transforming from swift hunters into the titans that would one day shake the earth with their footsteps. The golden age was theirs. The world united was theirs. And though Pangaea would not last forever, its legacy written in bone and scale would echo through time. Pangaea was a land of contradictions, a supercontinent where the elements waged war. In the heart of the supercontinent, the sun reigned unchallenged. Vast deserts stretched endlessly, their dunes shifting like waves frozen in time. The air here was a furnace, dry and searing, capable of sucking moisture from flesh in hours. Creatures that dared to cross these wastelands did so under the cover of twilight, their bodies adapted to endure the extremes. Scutosaurus, with its thick, scaly hide, trudged between sparse oases, while smaller reptiles buried themselves in the sand, waiting for nightfall. But the deserts were only one face of Pangaea's fury. To the north and south, monsoons ruled with brutal unpredictability. When the rains came, they did so in torrents, a deluge that turned parched riverbeds into raging floods overnight. The land, starved for water, drank greedily. Ferns and cycads exploded into life, their fronds unfurling in a matter of days. Swamps expanded, swallowing the lowlands, and with them came the predators. Crocodile-like Proterosuchids lurked in the newly formed marshes, their eyes barely breaking the surface as they waited for prey to stumble too close. Yet the monsoons were fleeting. As quickly as they arrived, they vanished, leaving behind a landscape caught between drowning and drought. Lakes evaporated under the relentless sun, their beds cracking into jagged mosaics. Amphibians, dependent on water for survival, either burrowed deep into the mud or perished. Only the hardiest reptiles thrived in this cycle of feast and famine, their metabolisms fine-tuned to endure scarcity. Along the coasts, the climate was no less extreme. Storms borne over the vast Panthalassa Ocean battered the shorelines with hurricane-force winds. Tidal surges reshaped the land, carving new inlets and drowning old ones. Marine reptiles like nothosaurs rode the turbulent waves, their streamlined bodies cutting through the chaos as they hunted fish and cephalopods. And then there were the mountains, towering, snow-capped sentinels that scraped the sky. Here the air was thin, the temperatures frigid. Few creatures ventured into these heights, but those that did were specialists. Small, fur-covered synapsids, distant relatives of mammals, clung to the rocky slopes, their dense coats insulating them against the cold. Pangaea's climate was a crucible. It forged resilience, punished weakness, and shaped evolution in ways no other force could. The reptiles that dominated this world did so because they could adapt to the blistering deserts, the drowning monsoons, the frozen peaks, and among them, the dinosaurs stood poised to inherit the earth. For in a land where survival was a battle against the elements, only the toughest would endure. The proof of Pangaea lay buried in stone. Centuries after the supercontinent's reign, its existence was pieced together not by living witnesses, but by the silent testimony of fossils scattered across the globe. Among the most compelling evidence were the remains of two unassuming creatures, Mesosaurus and Lystrosaurus. Mesosaurus, a small freshwater reptile no longer than a modern-day alligator, had once paddled through the shallow lakes and rivers of early Pangaea. Its slender body, equipped with needle-like teeth for catching fish, was ill-suited for ocean crossings, yet its fossils were found in two places separated by thousands of miles of open sea, eastern South America and southern Africa. Dr. Eleanor Voss, a paleontologist hunched over a limestone slab in a Namibian quarry, brushed away dust to reveal another Mesosaurus skeleton. Her fingers traced the delicate ribs, her voice barely above a whisper. This little swimmer couldn't have crossed an ocean. The salt water would have killed it. She glanced at her colleague, Dr. Raj Patel, who was examining a nearly identical specimen from Brazil. Which means, these lands were once connected. Raj finished, tapping the rock with his pick. No other explanation fits. Half a world away, in the frozen wastes of Antarctica, another team uncovered a different kind of proof. Lystrosaurus, a stout burrowing reptile resembling a pig with a beak, had been one of Pangaea's most successful survivors. Its fossils littered the rocks of India, South Africa, and now Antarctica, continents now separated by impassable waters. Dr. Lin Wei, her parka dusted with snow, held up a Lystrosaurus skull, its eye sockets staring vacantly into the past. This creature thrived in warm, arid climates, she said, her breath fogging in the cold air. Antarctica was once part of the same landmass, basking under the same sun. The implications were undeniable. These animals had lived and died on a single, unified continent, one that had since fractured and drifted apart. The fossil record was a map, and the map pointed to Pangaea. As the sun set over the dig sites, casting long shadows over the ancient bones, the scientists shared a quiet realization. The earth remembered, and in its stones the truth of a lost world endured. The story of Pangaea was written not just in bones, but in the very fabric of the land itself. Deep in the coal mines of India and Australia, workers uncovered seams of blackened plant matter, remnants of an ancient forest that had once spanned the supercontinent. Paleobotanist Dr. Elena Carter knelt beside a freshly split slab of coal, her gloved fingers brushing against the delicate imprint of a Glossopteris leaf. The fern-like plant with its distinctive tongue-shaped fronds had thrived in the humid lowlands of Pangaea over 250 million years ago. "These leaves are identical to the ones we found in South Africa and Antarctica," she murmured to her assistant, holding the fossil up to the dim lamplight. "Same veins, same structure. These plants grew across a single landmass, one that stretched from pole to pole." The coal beds themselves told another chapter of the story. Layer upon layer of compressed vegetation spoke of vast, swampy forests that had drowned and fossilized over millennia. These were the remains of Pangaea's lush heart, where towering lycophytes and giant horsetails had once swayed in the wind, only to collapse into peat and, under crushing pressure, transform into the coal that now fueled modern industry. But not all of Pangaea had been warm and green. High in the Rocky Mountains, geologist Dr. Marcus Boyd chiseled at a slab of sandstone, revealing parallel grooves etched into the rock, ancient scars left by something far colder than the desert sun. Glacial striations, he announced, tracing the marks with his thumb. These were carved by ice, massive sheets of it, grinding over the land like sandpaper. The discovery was baffling. Today, these mountains stood in a temperate zone, far from any ice caps, yet the striations matched those found in South Africa and Brazil, evidence of a time when these regions had huddled together near the South Pole, buried under a continental ice sheet. Pangaea wasn't just a tropical paradise, Marcus explained to his team, wiping sweat from his brow. It had frozen wastelands too. The glaciers moved in unison, scraping the same patterns across lands that are now oceans apart. The clues were everywhere: fossilized trees in Antarctica, coal beds beneath the sands of the Sahara, and ice scars on rocks now baking under the Brazilian sun. Each piece of evidence whispered the same truth: the world had once been whole. As the sun dipped below the horizon, casting long shadows over the dig sites, the scientists packed their finds with reverence. The Earth had left them a puzzle, scattered across continents and buried under layers of time, and with each fossil, each striation, they were one step closer to reconstructing the lost world of Pangaea. The Earth began to scream. Deep beneath Pangaea's surface, in the heart of what would one day be Siberia, a monstrous wound tore open in the planet's crust. Magma, pent up for eons, erupted in a cataclysm that dwarfed all volcanic fury before it. Fissures hundreds of miles long split the land like overripe fruit, vomiting rivers of molten rock that drowned entire regions in fire. The sky turned black with ash, blotting out the sun, and the air grew thick with the stench of sulfur. For the creatures of Pangaea, it was the beginning of the end. The Siberian traps, a flood basalt event of unimaginable scale, poured enough lava to bury continents. The eruptions did not cease for thousands of years. Each new surge of magma released torrents of carbon dioxide and methane, choking the atmosphere. Global temperatures spiked, turning the supercontinent into a furnace. Deserts cracked under the heat, and forests withered where they stood. In the shallow seas, the first casualties fell. Marine ecosystems collapsed as the waters became acidic, dissolving the shells of ammonites and brachiopods. Coral reefs, vibrant for millions of years, bleached and crumbled into lifeless rubble. Fish gasped in oxygen-starved shallows, their gills burning from the poison of hydrogen sulfide bubbling up from the depths. On land, the devastation was slower but no less complete. The early dinosaurs, small and adaptable though they were, found no refuge from the hellish conditions. Lystrosaurus, once a hardy survivor, now died in droves, its burrows flooding with toxic rain. Rivers evaporated, leaving behind cracked mudflats littered with the bones of creatures that had crawled there in a final desperate search for water. The skies offered no mercy. Acid rain fell in relentless sheets, scouring the soil of nutrients. The great Glossopteris forests, which had thrived for ages, rotted where they stood, their roots poisoned. Fires, sparked by lightning or lava, raced across the dead wood, turning the landscape into a smoldering wasteland. And still the eruptions continued. Volcanic winters alternated with suffocating greenhouse spikes, each cycle more brutal than the last. The food web unraveled. Herbivores starved as plants vanished. Carnivores turned on each other in cannibalistic frenzy. Entire lineages, tribalites, giant amphibians, ancient synapsids were snuffed out in a geological blink. By the time the fires burned themselves out, 90% of all life on Pangaea had perished. The supercontinent, once teeming, now lay silent under a haze of ash. The few survivors, small, scrabbling things, huddled in the ruins, waiting for the world to heal. The Great Dying was not merely an extinction. It was an apocalypse. And from its ashes, a new era would rise, but first, the Earth had to endure the void. Silence. The world after the Great Dying was a graveyard. The once vibrant supercontinent of Pangaea lay broken beneath a sky still choked with ash, its rivers running sluggish and black with decay. The air tasted of sulfur, and the sun, when it pierced the gloom, cast only a sickly pallor over the land. In the hollows between the skeletal remains of Glossopteris forests, the few survivors of the apocalypse stirred. Lystrosaurus, the pig-like reptile that had once been one of Pangaea's most common herbivores, now numbered in the hundreds where there had once been millions. Its beak, evolved for stripping tough vegetation, now gnawed at the few hardy ferns that clung to life in the poisoned soil. It was one of the lucky ones. Other creatures were not so fortunate. The mighty Dimetrodon, its sail-backed silhouette a symbol of an older world, had vanished entirely, its lineage snuffed out in the fires. The labyrinthodont amphibians, rulers of the swamps for millions of years, now rotted in drying ponds, their bodies bloated under the relentless heat. But nature abhors a vacuum. In the cracks of the devastation, life began its slow return. The first green shoots pushed through the ash, their leaves thin and desperate for sunlight. Insects, those eternal survivors, buzzed over the carcasses, their larvae feasting on the dead, and among them, small, quick-eyed reptiles darted, the ancestors of the dinosaurs. These were not the titans that would one day shake the earth. They were modest creatures, no larger than dogs, their bodies built for endurance rather than power. Euparkeria, a lithe bipedal predator, stalked the edges of the wastelands, its sharp teeth snapping at beetles and the occasional unwary lizard. It was an opportunist, a scavenger of a broken world. But the stage was set. Pangaea's vast, open landscapes, once a death trap under the scorching sun, now offered an advantage. With so few competitors left, the survivors could spread unchecked, their populations exploding in the absence of predators. The supercontinent's unity became their greatest weapon, a single, connected realm where the boldest could claim new territories with ease. As the millennia passed, the skies cleared, the volcanoes quieted, the earth, though scarred, began to heal, and in the hothouse world of the early Triassic, a new dynasty stirred. The dinosaurs were coming. Small at first, then larger, bolder, their adaptations honed in the crucible of extinction. They walked upright, their legs beneath them like pillars, their lungs efficient, their metabolisms relentless. They were the children of catastrophe, born from fire and forged in desperation. And Pangaea, still whole, still vast, would be their kingdom. The world was theirs. In the wake of the great dying, Pangaea's vast, open landscapes stretched like an empire waiting to be claimed. The supercontinent, still unified, offered endless horizons, lush floodplains, sun-baked deserts, and dense conifer forests, all connected by a single unbroken landmass, and into this emptiness the dinosaurs strode. At first, they were small. Coelophysis, no larger than a wolf, darted through the undergrowth on slender legs, its lithe body built for speed. Its hollow bones made it light, its sharp, serrated teeth made it deadly. Packs of these predators hunted the riverbanks, their calls sharp and bird-like as they coordinated to bring down larger prey. Nearby, Platosaurus, an early giant, towered over the vegetation, its long neck stretching to strip leaves from the tallest trees. Though not yet the behemoths of later eras, these creatures were the vanguard of a dynasty that would rule for millions of years. Pangaea's unity was their greatest advantage. With no oceans to divide them, species spread unchecked, adapting to every corner of the supercontinent. A Coelophysis born in the arid heart of what would one day become North America could, over generations, find its descendants stalking the shores of future Africa. Genetic diversity exploded as populations mingled, competing and evolving under the same relentless sun. The deserts, once lethal, became mere obstacles. Dinosaurs, with their efficient respiratory systems and scaly hides that minimized water loss, crossed the dunes where other creatures faltered. The monsoons, though brutal, nourished the land in cycles of plenty. Floodplains teemed with fish, and herds of Platosaurus migrated with the rains, their footprints etching highways into the mud. Predators and prey danced an ancient rhythm. Colophysis hunted in coordinated strikes, their sickle claws flashing, while smaller reptiles like Proterosuchus lurked at the water's edge, waiting to ambush the unwary. But the dinosaurs were different. They were faster, smarter, their metabolisms humming with energy. When food was scarce, they endured. When the climate shifted, they adapted. And then they grew. With no natural barriers to limit their spread, and no rivals to challenge their dominance, the dinosaurs evolved into giants. Plateosaurus, once a modest herbivore, ballooned in size, its descendants destined to become the long-necked titans of the Jurassic. Theropods, ancestors of Tyrannosaurus, grew bolder, their jaws stronger. Pangaea had forged them in fire and famine. Now it crowned them. The age of reptiles had reached its zenith. The dinosaurs ruled, not by chance but by the sheer, unyielding force of evolution. And as their footsteps shook the earth, the supercontinent, still whole, still vast, bore witness to the dawn of their empire. For now the world was united, and the dinosaurs were its kings. The Earth's fury could no longer be ignored. What had begun as faint tremors and hairline fractures now erupted into chaos. Across Pangaea's spine, volcanoes roared to life, their plumes of ash blotting out the sun for weeks at a time. Lava fountains spewed molten rock high into the air, painting the night sky in hues of blood and gold. The land itself seemed to breathe, expanding, cracking, sinking in a violent dance of destruction and rebirth. In the rift valleys between what would become Africa and South America, the ground split like overstretched leather. Great slabs of crust collapsed inward, forming jagged basins that hissed with geothermal vents. Rivers, once steady and predictable, now vanished overnight, swallowed by the widening gaps. Dr. Elias Carter stood at the edge of one such chasm, the heat of the exposed mantle searing his face. "It's accelerating," he shouted over the rumble of another quake. His boots slipped on the crumbling rock as he gestured to the team's seismographs, their needles spiking erratically. "The plates are pulling apart faster than we predicted." Nearby, a herd of Plateosaurus bellowed in alarm as the ground beneath them shuddered. One stumbled, its massive frame crashing into the dirt as a new fissure yawned open beside it. The dinosaurs scattered, their instincts screaming of danger. No claws or teeth could fight. The oceans, sensing weakness, began their invasion. Salt water seeped into the lowest rifts, boiling away instantly only to be replaced by more, again and again, until new briny lakes formed in the depths. Steam explosions rocked the landscape, sending superheated geysers shooting into the air. The air reeked of sulfur and salt, a metallic tang that clung to the scales of every creature that dared to breathe it in. And still the fractures spread. Thousands of miles to the north, the crust groaned under the weight of the shifting plates. Mountain ranges, once stable, now trembled as their foundations were undercut. Avalanches of rock and dirt cascaded down slopes, burying valleys in seconds. The great conifer forests, survivors of countless droughts, now toppled like kindling, their roots torn from the destabilized earth. Pangaea was unraveling. The supercontinent that had nurtured the dinosaurs' rise was now their greatest threat. The very unity that had allowed them to dominate the planet now meant there was no escape, no isolated refuge from the devastation. Every tremor, every eruption, every flood of lava echoed across the land, a relentless drumbeat of doom. Yet even in the chaos, life clung on. Small reptiles burrowed deeper, their bodies pressed into the cool earth as if trying to outwait the apocalypse. The hardiest plants, cycads and ferns with roots like iron, stubbornly regrew in the ash-choked soil. And the dinosaurs, those swift, cunning survivors, adapted as they always had. Some migrated toward the coasts, where the ground was still stable. Others followed the shifting rivers, their instincts guiding them to pockets of safety. But the message was clear. The age of a united world was ending. The cracks would not stop. The rifts would not heal. Pangaea, the All-Earth, was dying. and from its broken body, new lands, new worlds would rise. The seas reclaimed their dominion. Where once there had been unbroken land, salt water now surged through the widening gashes in Pangaea's flesh. The Tethys Ocean, long constrained by the supercontinent's bulk, rushed into the rift valleys between Africa and Eurasia, its turquoise waves swallowing sunken forests and drowned mountain ranges. To the west, the Pangaea, already vast, stretched its hungry fingers into the newborn Atlantic, carving a seaway between the Americas and Africa. The world was coming undone. Dr. Elias Carter stood on the crumbling edge of a coastal cliff, watching as the ocean below gnawed at the land. "It's happening faster than we thought," he said, his voice barely audible over the roar of the surf. His boots crunched on fossilized Glossopteris leaves embedded in the rock, remnants of a forest that had once thrived hundreds of miles inland. Now those ancient trees lay submerged beneath the rising tide. His colleague, Dr. Nadia Ruiz, adjusted her binoculars, tracking a pod of ichthyosaurs slicing through the newly formed strait. "Look at them," she murmured. "They're already treating this like it's always been here. And why wouldn't they?" The oceans had been patient. For millions of years they had lapped at Pangaea's shores, waiting for the land to weaken. Now, with tectonic forces as their allies, they advanced relentlessly. Coastlines that had stood firm for epochs crumbled overnight. Islands, future fragments of continents, were born in eruptions of steam and basalt. The climate, too, bowed to the change. With vast bodies of water now dividing the land, weather patterns fractured. The monsoons that had once drenched Pangaea's heart weakened, their power diffused by the new seas. Coastal regions grew humid, their air thick with salt and the scent of kelp, while the interior deserts, no longer tempered by oceanic winds, became even more extreme. Temperatures swung wildly between day and night, and dust storms raged across the barren plains. For the dinosaurs, it was a world remade. Herds of Plateosaurus, once able to roam unimpeded, now found their migrations blocked by impassable straits. Predators like Coelophysis patrolled shrinking territories, their hunting grounds bisected by the encroaching waves. Isolation bred divergence. Populations separated by water began to evolve in strange new directions. On landmasses not yet fully severed, the last remnants of Pangaea's unity played out in real time. A Coelophysis in what would become Morocco might still resemble its cousin in future Brazil, but their descendants, given time, would become unrecognizable to one another. Yet the oceans were not done. Beneath the waves, undersea volcanoes built new chains of islands, their peaks steaming above the surf. Coral reefs, those bustling metropolises of the sea, colonized the sunken edges of the continents, their vibrant hues a stark contrast to the muted tones of the dying supercontinent. Marine reptiles, ichthyosaurs, plesiosaurs, darted through the labyrinth of underwater canyons, their bodies sleek and perfect for this expanding blue world. Pangaea's legacy was written in the very water that now drowned it. The Tethys and Pangaea, once servants to the land, had become its conquerors, and as the last land bridges vanished beneath the waves, the dinosaurs faced a new reality. Their empire, once boundless, was now a collection of islands. The age of isolation had begun, and with it, evolution prepared its next masterpiece. The world was breaking apart, and life surged forth to fill the cracks. As Pangaea fractured, its once unified landscapes became a patchwork of isolated realms. The great inland deserts, now severed by newborn seas, bloomed into lush floodplains where rivers meandered unchecked. Coastal regions, once arid under the supercontinent's rain shadow, grew humid with ocean breezes, their forests thickening into dense jungles. And in these new fragmented worlds, the dinosaurs flourished like never before. In the north, where the rifting land would one day become North America and Europe, Allosaurus ruled as the apex predator. 25 feet of muscle and serrated teeth, it stalked the fern-choked valleys, its amber eyes scanning for movement. A herd of Stegosaurus, massive, plate-backed herbivores, grazed nearby, their spiked tails twitching at the slightest sound. When the Allosaurus lunged, the herd closed ranks, their thagomisers swinging in deadly unison. The predator retreated, hissing, but there would be other hunts. The land was rich with prey. Meanwhile, in the southern reaches, future Africa and South America, a different ecosystem thrived. Here, the air hung heavy with moisture, and towering conifers dripped with morning dew. Brachiosaurus, their necks stretching impossibly high, stripped leaves from the canopy while smaller ornithopods darted between their legs. The rivers teemed with fish, and pterosaurs skimmed the water's surface, their wings casting fleeting shadows. Isolation bred diversity. With oceans now dividing the land, populations that had once mingled freely were left to evolve in solitude. A Stegosaurus in the north grew thicker plates for display, while its southern cousins developed longer tail spikes for defense. The Allosaurus, no longer competing with predators from other regions, diversified into specialized hunters, some with broader skulls for crushing bone, others with narrower snouts for precision strikes. Yet the ghosts of Pangaea lingered. In the rock layers of distant continents, paleontologists would later find identical fossilized footprints, evidence that these creatures had once shared a single world. A Stegosaurus track in Portugal matched one in Colorado. A Brachiosaurus femur in Tanzania mirrored its counterpart in Argentina. The Earth remembered its unity, even as it tore itself apart. For now, though, the dinosaurs knew only their own corners of the globe. The Allosaurus did not wonder what lay beyond the eastern sea. The Brachiosaurus did not miss the northern deserts. They lived in the moment, their bodies and behaviors fine-tuned to their new, isolated paradises. But the divisions were not yet complete. Land bridges, tenuous and fleeting, still connected some regions. Migrants crossed them in rare moments of climatic calm. A lone Ceratosaurus wandering into unfamiliar territory, a cluster of Diplodocus venturing beyond their ancestral ranges. These stragglers carried with them the last echoes of Pangaea's unity, their genes mingling with isolated populations before the seas rose again to cut them off. The Jurassic world was a mosaic, each fragment a vibrant masterpiece of adaptation. And as the continents drifted further apart, the dinosaurs, once rulers of a single kingdom, would become kings of many. The age of giants had only just begun. The dance of divergence had begun. As Pangaea's fragments drifted farther apart, the oceans between them became insurmountable barriers. No longer could a Stegosaurus wander from what would become Colorado to Portugal. No longer could a Brachiosaurus cross from Tanzania to Argentina. Isolated now, each landmass became a crucible for evolution, forging unique ecosystems where dinosaurs adapted in astonishing ways. In the north, where the Atlantic's embryonic waters had not yet fully severed Europe from North America, the forests hummed with life. Allosaurus, the undisputed king of these realms, grew larger, their jaws capable of crushing bone. But they were not alone. Smaller predators like Ceratosaurus, with their distinctive nasal horns, prowled the undergrowth, their builds leaner for chasing fleet-footed prey. The herbivores, too, diversified. Stegosaurus developed staggered plates that shimmered in the sunlight, possibly for display, while Camptosaurus evolved longer legs to outrun their pursuers. Across the widening Tethys, the southern continents told a different story. In the dense jungles of prehistoric South America, Giganotosaurus, a theropod even larger than Allosaurus, ruled the food chain. Its prey, the titanic Argentinosaurus, moved in herds so vast their footsteps mimicked earthquakes, their long necks stripping entire groves of foliage in minutes. Here, the arms race between predator and prey escalated to staggering proportions, each pushing the other to extremes of size and strength. Meanwhile, on land masses like Australia and Antarctica still tenuously connected, the dinosaurs took stranger paths. With months of darkness during polar winters, some species developed insulating feathers, their bodies compact and efficient to conserve heat. Fossils would later reveal small, hardy ornithopods with enlarged eyes, likely an adaptation to the dim light, and predators with serrated teeth designed to pierce thick hides frozen by frost. The oceans, too, teemed with new life. As the seas expanded, marine reptiles like Plesiosaurus and Ichthyosaurus flourished, their streamlined bodies perfect for hunting fish in the deepening waters. Coral reefs, now free to grow along the sundered continental shelves, became bustling metropolises of biodiversity, sheltering creatures that would never have thrived in Pangaea's confined coastal zones. But it was the skies that witnessed the most breathtaking transformation. Pterosaurs, once limited in variety, now exploded into myriad forms. On the northern continents, Rhamphorhynchus darted over lagoons, their long tails stabilizing flight as they plucked fish from the water. In the south, Pterodactylus soared on broader wings, their toothless beaks adapted for snatching small reptiles and insects from the forest canopy. With no land barriers to hinder their spread, these flying reptiles colonized every coastline, their shadows flickering over beaches and cliffs alike. Yet for all this diversity, traces of shared ancestry remained. A Giganotosaurus in South America and an Allosaurus in North America, though separated by an ocean, still moved with the same calculated grace, their builds refined from a common ancestor that had once roamed Pangaea's open plains. The fossil record would later reveal these echoes, a vertebra here, a claw there, whispering of a time when the world was one. For now, though, the dinosaurs knew only their own realms. The Argentinosaurus did not miss the conifer forests of the north. The Ceratosaurus did not long for southern jungles. They were creatures of their time and place, their bodies and behaviors honed by the lands that birthed them. But the divisions were not yet absolute. Occasionally, a storm would carry a lost pterosaur across the sea, or a raft of vegetation would ferry a small dinosaur to foreign shores. These chance migrants brought with them the last threads of Pangaea's genetic tapestry, weaving fleeting connections between worlds that would soon be strangers. The Jurassic was no longer an age of unity, but of splendid isolation, and from this fragmentation, life's greatest experiments would arise, each landmass a laboratory, each species a masterpiece of adaptation. The dinosaurs, once rulers of a single kingdom, had become emperors of many, and their reign, though divided, was far from over. The final act of Pangaea's dissolution was written in fire and water. By the dawn of the Cretaceous, the supercontinent had fractured beyond recognition. The Atlantic Ocean, once a mere fissure, now yawned wide between the Americas and Africa, its currents carving deeper channels with each passing millennium. The Tethys Sea, a shimmering expanse of blue, swallowed the last land bridges between Eurasia and the southern continents. Where there had once been unity, there was now only separation, vast, unbridgeable, and irreversible. Dr. Elias Carter stood on the prow of a research vessel, his hands gripping the railing as the ship cut through the waves of the newborn Atlantic. The coastline of Brazil, lush and green, was a fading smudge on the horizon. Ahead lay Africa, no longer a neighbor but a distant shore. "It's done," he murmured, his voice barely audible over the wind. "Pangaea is gone." His colleague, Dr. Nadia Ruiz, adjusted the sonar display, its screen flickering with the contours of the ocean floor. "Look at this," she said, tracing a jagged rift valley with her finger. "The crust is still spreading. The Atlantic grows wider by an inch every year. Beneath them, the Earth's mantle surged upward, cooling into new sea floor as the continents drifted apart. Submarine volcanoes dotted the abyss, their vents spewing mineral-rich plumes that fed bizarre ecosystems of tube worms and blind shrimp. The ocean was alive, restless, its birth pangs still echoing through the depths. On land, the consequences were profound. The dinosaurs, once rulers of a unified world, now faced a planet of islands. In North America, Tyrannosaurus rex stalked the floodplains, its bone-crushing jaws a testament to the arms race of an isolated continent. Across the Atlantic, in Africa, Spinosaurus prowled the river deltas, its crocodilian snout and sail-backed silhouette a stark contrast to its northern cousin. Evolution, no longer constrained by Pangaea's unity, had spun wild variations on the dinosaurian theme. The climate, too, had shifted. With oceans now dominating the globe, temperatures grew milder, the extremes of Pangaea's interior deserts softened by maritime winds. Rainforests sprawled across the equator, their canopies teeming with life. Feathered dinosaurs like Microraptor flitted between the trees, while giant pterosaurs such as Quetzalcoatlus rode the thermals overhead. Even Antarctica, not yet frozen, hosted lush forests where small ornithopods foraged under the midnight sun. Yet the legacy of Pangaea lingered. In the rock layers of distant continents, paleontologists would later find identical fossils, proof of a shared ancestry. The iguanodon, a bulky herbivore, left its footprints in both England and Montana. The Carcharodontosaurus, a predator rivaling T-Rex, hunted in lands that would one day be called Africa and South America. The Earth remembered its unity, even as its pieces scattered. For now, though, the dinosaurs knew only their own fragmented realms. The Triceratops of North America did not mourn the loss of its African cousins. The Majungasaurus of Madagascar did not long for the plains of India. They were creatures of their time and place, their destinies shaped by the drifting continents beneath their feet. And drift they did. The Atlantic widened. The Tethys shrank, its waters retreating as Africa collided with Eurasia, birthing new mountain ranges in a slow-motion crash. Australia, once snug against Antarctica, began its lonely journey northward. The world map, once a single mass, now resembled the fractured puzzle of modernity. The Cretaceous was the age of parting, of isolation, of glorious, terrible diversity. Pangaea, the all-earth, was no more, but from its ashes a new world had risen, one of oceans and archipelagos, of giants and innovators, of life unshackled and set free. The dinosaurs, though divided, would reign for millions of years yet, but their time too was finite. And the Earth, ever restless, had already begun to dream of what would come next. The world belonged to titans. By the late Cretaceous, the fragmented continents had become kingdoms of scale and savagery, each ruled by predators and prey of staggering proportions. The dinosaurs, once modest survivors of Pangaea's ruins, had evolved into colossi, perfectly adapted to their isolated realms, yet bearing the unmistakable echoes of their shared ancestry. In the floodplains of North America, Tyrannosaurus rex stalked the twilight, its 6-ton frame shaking the earth with each step. Its jaws, capable of crushing bone with 12,800 pounds of force, were the ultimate killing tools, honed over millennia of relentless competition. A herd of Triceratops, their massive frills and 3-foot-long horns glinting in the sunset, formed a defensive circle as the predator approached. The air thrummed with tension, a standoff between two species sculpted by the same unforgiving world. Across the Atlantic, in the mangrove-choked deltas of prehistoric Africa, Spinosaurus reigned supreme, towering even taller than Tyrannosaurus. Its crocodilian snout and conical teeth were built for snatching fish from murky waters, though it would not hesitate to scavenge or hunt smaller dinosaurs when opportunity arose. Its sail, a 6-foot-tall lattice of skin and bone, cast an ominous shadow over the riverbanks, a warning to all who dared challenge its dominion. Meanwhile, in South America, Giganotosaurus and Argentinosaurus played out an ancient dance of predator and prey. The theropod, nearly as large as T-Rex but lighter and faster, hunted in packs, its serrated teeth designed to bleed its quarry dry. The sauropod, stretching over 100 feet from snout to tail, moved in earth-shaking herds, their sheer bulk their only defense. When the hunt began, the forest trembled, a spectacle Pangaea's early dinosaurs could never have imagined. Isolation had bred specialization. On the island continents like Madagascar, Majungasaurus, a thick-skulled, short-armed predator, ruled as the apex carnivore, its bone-crunching bite adapted to a land of limited resources. In Antarctica, which still clung to the vestiges of its temperate climate, smaller feathered theropods like Impuribata darted between the ferns, their insulated bodies built for endurance in the cool air. The herbivores, too, had reached new heights. Ankylosaurus, armored like a living fortress, swung its clubbed tail with enough force to shatter a predator's leg. Parasaurolophus, its long trumpet-like crest resonating with low-frequency calls, communicated across vast distances, a necessity in a world where oceans now divided their kind. Yet for all their divergence, the giants shared a common thread. Their upright stances, efficient lungs, and relentless metabolisms were the legacy of Pangaea, traits forged in the supercontinent's crucible and perfected in its shattered remains. A T-Rex embryo, had it been transplanted to Argentina, might have grown into something resembling Giganotosaurus. Evolution, though shaped by isolation, still whispered of unity. The skies and seas, too, teemed with giants. Quetzalcoatlus, a pterosaur with a wingspan rivaling a small plane, rode the thermals over inland seas, its sharp eyes scanning for carcasses. In the deepening oceans, Mosasaurus, a 50-foot marine lizard, ruled the waves, its conical teeth crushing ammonites and plesiosaurs alike. But the age of giants was not eternal. Even as Tyrannosaurus and Triceratops clashed in the forests of Montana, even as Spinosaurus prowled the African deltas, the Earth was preparing its next cataclysm. The continents, still drifting, still changing, carried their rulers toward an inevitable reckoning. For now, though, the dinosaurs stood unchallenged. They were the last, greatest monarchs of a world Pangaea had made and unmade. And their reign, though magnificent, was fleeting. The sky burned. It began as a distant glint, a speck of light hurtling through the void, unnoticed by the creatures below. Then in an instant it swelled into a fireball, its brilliance eclipsing the sun. The asteroid, 6 miles wide and traveling at 45,000 miles per hour, struck the Earth with the force of 1 billion atomic bombs. The impact point, a shallow sea off the Yucatan Peninsula, vaporized instantly. Water turned to steam. Rock melted into molten glass. A shockwave radiated outward at hypersonic speeds, flattening forests thousands of miles away. The very air ignited, superheated into a furnace that set the world ablaze. In the jungles of what would one day become Montana, a Tyrannosaurus raised its massive head, nostrils flaring at the acrid scent of smoke. The ground trembled, then buckled. Trees toppled like twigs as the seismic waves tore through the continent. The tyrannosaur bellowed, a sound of primal confusion, before the firestorm reached it. The inferno swept across the land, incinerating everything in its path. Leaves curled to ash, rivers boiled dry. The great predator had no time to flee. Along the coasts, tsunamis 1/2 mile high roared inland, scouring the landscape of all life. Triceratops herds caught in the open were swept away like driftwood. The waves carried their massive bodies miles inland, depositing them in tangled heaps among the shattered remains of forests. The sky darkened. Dust, ash, and vaporized rock billowed into the stratosphere, blotting out the sun. Temperatures plummeted as the planet plunged into a global winter. Photosynthesis ground to a halt. Plants withered. Herbivores starved. Carnivores turned on each other in desperate cannibalistic frenzy. Acid rain fell in toxic sheets, poisoning the soil and the few remaining water sources. The oceans fared no better. Plankton, the base of the marine food web, died en masse. Ammonites and marine reptiles gasped in oxygen-deprived waters, their bodies sinking into the depths. Coral reefs, vibrant for millions of years, bleached and crumbled into lifeless rubble. The reign of the dinosaurs ended not with a whimper but with a scream, a chorus of agony from every corner of the globe. The impact winter dragged on for years, then decades. Survival was a lottery, and the dinosaurs held no winning tickets. But in the shadows, small creatures stirred. Mammals, tiny, furred and long overshadowed, dug deep into burrows, their high metabolisms and omnivorous diets allowing them to endure where the giants could not. Birds, the last feathered descendants of theropods, flitted through the poisoned skies, their hollow bones light enough to subsist on scarce resources. The earth had been reset, and from the ashes of the old world, a new one would rise. Silence. The world after the impact was a graveyard. The skies, once ruled by pterosaurs and birds, now hung heavy with ash, filtering the sun into a dim, blood-red orb. The forests were gone, reduced to fields of blackened stumps and smoldering earth. Rivers ran thick with sediment, their waters lifeless and still. The air reeked of sulfur and charred bone. In the ruins of what had once been a lush floodplain, a small furry creature emerged from its burrow. Its whiskers twitched as it sniffed the air, its beady eyes scanning the wasteland for danger. This was Purgatorius, an early primate ancestor, no larger than a rat. For millions of years its kind had scurried in the shadows of the dinosaurs, surviving on insects and fallen fruit. Now, with the giants gone, the world was theirs to inherit. Across the globe, similar scenes played out. Mammals, long suppressed by the dinosaurs' dominance, ventured into the open, their populations exploding in the absence of predators. Some, like the pig-sized Ectoconus, grew bolder, their bodies adapting to fill the niches left vacant by the vanished herbivores. Others, like the carnivorous Cymelestes, stalked the undergrowth, their sharp teeth perfect for hunting the few remaining reptiles and insects. The dinosaurs had not disappeared entirely. High in the skeletal remains of the forests, a handful of bird species clung to life. Their feathers, once vibrant, were now dull with soot, their songs reduced to hoarse croaks. They were the last descendants of the theropods, tiny, fragile echoes of a dynasty that had once shaken the earth. Over time, they would diversify, their wings carrying them to new heights, but for now, they were survivors, nothing more. In the oceans, the devastation was equally complete. The great marine reptiles, Mosasaurus, Plesiosaurus, had perished in the toxic tides, their bodies sinking into the abyss. The ammonites, with their spiral shells, were extinct, their fossilized remains destined to litter future seafloors. Only the hardiest fish and crustaceans endured, their numbers slowly rebounding in the void. Yet life, as it always had, found a way. Ferns, those ancient pioneers, were the first plants to return, their fiddleheads unfurling in the ashen soil. Cycads followed, their tough fronds resistant to the lingering acid rain. With them came insects, beetles and ants that fed on the decaying matter, their populations exploding in the absence of predators. The food web, though shattered, was rebuilding itself, link by tenuous link, and the mammals were ready. Their small size, once a liability, had become their salvation. They required less food, reproduced quickly, and could hide from the worst of the elements. Their warm blood kept them active in the cooling world, and their varied diets allowed them to exploit every available resource. Over the millennia, they would grow larger, more diverse, branching into ungulates, carnivores, primates. The age of reptiles had ended, the age of mammals had begun, but the earth remembered. In the rocks of every continent, the bones of the dinosaurs lay entombed. Tyrannosaurus in Montana, Triceratops in the Dakotas, Spinosaurus in Morocco. Their fossils, buried in layers of sediment, would one day tell the story of their rise and fall. The impact crater itself, hidden beneath the Yucatan, would remain as a silent testament to the cataclysm that had reshaped the world. For now, though, the planet was quiet. The winds carried no roars, the earth no tremors of titanic footsteps. The age of giants was over, and in the hush of their passing, the future stirred, small, quick, and alive with possibility. The world had shattered, but its fragments remembered. As the continents drifted apart, each carried with it a living heirloom, species shaped by Pangaea's unity, now evolving in isolation. The supercontinent's legacy was written in the DNA of creatures separated by oceans, yet bound by shared ancestry. Nowhere was this more evident than in Australia. Cut off from the rest of the world for over 50 million years, the island continent became a sanctuary for lineages long vanished elsewhere. Marsupials, mammals that carried their young in pouches, had once scurried in the shadow of dinosaurs across Pangaea. But as placental mammals rose to dominance on other continents, marsupials in Australia, free from competition, flourished. Kangaroos bounded across open plains, their powerful legs adapted for endurance in the arid outback. Koalas clung to eucalyptus trees, their slow metabolisms fine-tuned to the toxic leaves. The Tasmanian devil, a relic of a bygone era, prowled the underbrush, its bone-crushing jaws echoing the ferocity of its Cretaceous ancestors. Dr. Eleanor Voss knelt in the red dust of the outback, brushing sand from the skull of a thylacoleo, Australia's long-extinct marsupial lion. This predator, she murmured to her team, was the apex carnivore here for millions of years. Its ancestors walked Pangaea alongside early dinosaurs. She turned the fossil in her hands, tracing the ridges of its saber-like teeth. Isolation preserved them. Half a world away, on the island of Madagascar, another echo of Pangaea endured. Lemurs, bright-eyed, nimble primates, leaped through the island's dense rainforests, their ancestors having rafted there on floating vegetation long after the supercontinent fractured. But Madagascar's true marvels were stranger. The fossa, a sleek cat-like carnivore, was the island's top predator, its lineage tracing back to mongoose relatives that had arrived when the landmass still brushed against Africa. Giant tortoises, descendants of ancient reptiles that had once roamed Pangaea's deserts, lumbered through the undergrowth, their shells weathered by centuries. Madagascar is a time capsule, said Dr. Raj Patel, crouching beside a trap that had caught a tiny mouse lemur. These creatures evolved here with no interference from mainland competitors. It's like seeing a snapshot of evolution frozen in amber. The same story unfolded across the globe. In South America, where the continent had drifted in solitude for eons, bizarre mammals like the glyptodon, a car-sized armadillo relative, evolved in parallel to their African and Eurasian counterparts. The terror birds, flightless predators with axe-like beaks, ruled as apex carnivores long after their dinosaur ancestors had perished. Only when the Isthmus of Panama formed, bridging North and South America 3 million years ago, did these isolated worlds collide with catastrophic consequences for the natives. Even the oceans bore Pangaea's fingerprints. The freshwater stingrays of the Amazon and the Congo shared a common ancestor that had swam the rivers of the supercontinent before the Atlantic tore them apart. Their DNA, diverging over millennia, still whispered of their shared origins. Yet the most profound legacy of Pangaea was not in the species that survived, but in the patterns they left behind. Biogeography, the study of life's distribution, revealed the ghost of the supercontinent in every ecosystem. The flightless ostriches of Africa, the rheas of South America, and the emus of Australia were all descendants of a single lineage of birds that had spread across Pangaea before its breakup. Their wings, no longer needed in a land without predators, had atrophied in eerie unison across continents. The Earth, though fractured, still told its story. And as the sun set over the outback, painting the sky in hues of fire and gold, Dr. Voss packed her fossils with quiet reverence. The marsupials, the lemurs, the relic reptiles, they were all pieces of a puzzle 300 million years in the making. Pangaea was gone, but its children endured. The mountains remembered. From the jagged peaks of the Appalachians to the weathered spine of the Atlas Range, the earth bore scars that whispered of Pangaea's existence. These mountains, now separated by oceans, had once been part of the same colossal range forged in the fiery collision that birthed the supercontinent. Dr. Marcus Boyd traced his fingers along a granite outcrop in Morocco. his palm brushing against striations that mirrored those he'd studied in the Appalachian foothills of Pennsylvania. "Same rock, same age, same formation," he murmured. "Only an ocean between them now." His team had spent months comparing the mineral composition of these distant ranges, and the evidence was irrefutable. The Atlas Mountains of North Africa and the Appalachians of North America were geological twins, torn apart by the same tectonic forces that had shattered Pangaea. The quartz veins, the folded metamorphic layers, even the fossilized ripple marks from ancient streams, all matched perfectly, like pages ripped from the same book. But the rocks were not the only witnesses. In the sedimentary layers of Brazil and South Africa, paleontologists uncovered identical sequences of Permian-era fossils, freshwater reptiles, ferns, and even insect imprints locked in stone like snapshots of a shared past. Dr. Lin Wei, crouched in a Brazilian quarry, held up a slab of shale bearing the delicate imprint of a Glossopteris leaf. "This is the same species we found in South Africa," she said, her voice hushed with awe. "The same veins, the same serrated edges. These plants grew in the same soil before the continents tore apart." The fossil record was a trail of breadcrumbs leading back to Pangaea. In India, coal seams rich with Glossopteris remnants lay buried beneath the Himalayas, proof that the subcontinent had once been nestled against Antarctica, where identical deposits were found. In Antarctica itself, geologists chipped away at ice-covered bedrock to reveal glacial striations that aligned perfectly with those in South Africa and Australia, all carved by the same ancient ice sheet when these lands were joined at the South Pole. Even the ocean floors held clues. Sonar mapping of the mid-Atlantic ridge revealed symmetrical bands of magnetized rock, a zebra-stripe pattern recording the slow, relentless spreading of the seafloor as the Americas drifted away from Africa. "It's like a geological tape recorder," Dr. Nadia Ruiz explained, pointing to the sonar display aboard her research vessel. "Each stripe is a reversal of Earth's magnetic field, frozen in time as the magma cooled, and they mirror perfectly on either side of the ridge." The evidence was overwhelming. From the matching jigsaw edges of continental shelves to the shared DNA of species separated by oceans, the ghost of Pangaea lingered in every layer of the planet. The supercontinent's breakup had not been an erasure, but a transformation, a scattering of pieces that still bore the marks of their origin. As the sun dipped below the horizon, casting long shadows over the Moroccan cliffs, Dr. Boyd packed his rock samples with care. The mountains, the fossils, the seafloor, they were all chapters in a story written in stone. Pangaea was gone, but the Earth would never forget. The Earth's dance was never-ending. Long after Pangaea had fractured into the continents we know today, the restless mantle beneath the crust continued its slow, inevitable churn. The plates that carried the landmasses drifted still, their movements measured in centimeters per year, imperceptible to human eyes, but undeniable over geologic time, and just as Pangaea had once formed from the collision of Gondwana and Laurasia, so too would the scattered continents one day reunite. Scientists had a name for this future colossus: Amasia. Dr. Eleanor Voss stood before a holographic projection in her lab, the glowing continents shifting like pieces on a cosmic chessboard. North and South America, having drifted westward for millennia, would eventually collide with Eurasia. Africa, already pressing northward into Europe, would fuse with the landmass, closing the Mediterranean Sea forever. Australia, creeping steadily toward Asia, would become part of the new supercontinent's southern flank. Antarctica, freed from its icy isolation, might finally join the world. "It won't happen tomorrow," Dr. Voss said to her students, tracing the projected paths with a laser pointer. "But in 250 million years, the map will look like this." The hologram solidified into a single massive landmass, encircled by a global ocean even vaster than Panthalassa. The implications were staggering. Amasia's formation would reshape the planet's climate, its geography, its very life. With most land clustered near the equator, deserts would sprawl across the interior, their dunes shifting under relentless sun. The poles, devoid of continents, might freeze into even more expansive ice caps. Monsoons, no longer tempered by fragmented coastlines, would lash the supercontinent's edges with biblical fury. And life would adapt as it always had. Mammals, birds, whatever descendants of ours remain, will face the same challenges the dinosaurs did on Pangaea, Dr. Voss continued. Extreme weather, limited habitats, but also opportunity. She zoomed in on the simulation, where digital flora and fauna spread across Amazia's hypothetical landscapes. Evolution thrives in isolation, but supercontinents force innovation. New predators, new prey, new ecosystems born from the collision of old ones. The students murmured, their eyes wide. One raised a hand. Could humans survive that? Dr. Voss smiled faintly. If our species lasts that long, we'd have to be very different creatures by then. But life will find a way. It always has. The hologram flickered, cycling backward through time. Amazia dissolving into the modern world, then further back to Pangaea, and further still to Rodinia, the supercontinent that predated even that. The Earth's history was a loop, not a line, and the cycle would continue. After Amazia, the mantle's heat would build once more. The crust would thin, rifts would form, and the supercontinent, like all those before it, would fracture, its pieces cast adrift on the molten currents below. New oceans would yawn between them. New islands would rise from the depths. And somewhere, in the distant future, another supercontinent would be born. The Earth was never finished. Its story was never complete. As the lab lights brightened and the hologram faded, Dr. Voss folded her arms, gazing at the static world map on the wall. The continents seemed so permanent, so fixed. But she knew better. Pangaea was just one chapter. Amazia would be the next, and the dance would go on. The Earth never stopped moving. In a quiet lab at the California Institute of Technology, Dr. Samuel Reyes adjusted the GPS monitor, its screen flickering with real-time data. The numbers told a story of imperceptible motion. North America creeping westward at the speed of a growing fingernail, Australia inching northward, Africa slowly fracturing along the East African rift. See this? He tapped the screen, where a red line charted the movement of a geodetic station in Colorado. 2 centimeters per year. Not much, but over 1 million years? That's 20 kilometers. His colleague Dr. Amina Okoye leaned in, her brow furrowed. And it's the same forces that pulled Pangaea apart, she murmured. Exactly. Samuel pulled up a seismic map, the tectonic plates outlined like jagged puzzle pieces. The mantle's convection currents haven't changed. What drove Gondwana and Laurasia together, what shattered them later, it's all still happening. The evidence was everywhere. Satellite measurements showed the Atlantic widening, the Pacific shrinking. Earthquakes rippled along the mid-Atlantic ridge as magma welled up, hardening into new crust. Even the Himalayas, still rising as India plowed into Eurasia, were a testament to the same forces that had once built Pangaea's mountains. Amina scrolled through a simulation on her tablet, a time-lapse of the last 200 million years. Continents drifted, collided, fractured. We're living in the aftermath, she said, but also in the prelude. The cycle isn't over. Outside, the ground beneath their feet, solid, unchanging to human senses, was alive with motion. The same forces that had forged and broken a supercontinent still shaped the world. Quietly, relentlessly, the Earth continued its dance. And the clues were there, for those who knew how to look. The same forces that once tore Pangaea apart still shape our world today, through earthquakes, volcanoes, and the slow birth of mountains. Dr. Samuel Reyes stood in a seismology lab, his fingers hovering over a 3D model of the Pacific Ring of Fire. The display pulsed with red dots, each marking a recent earthquake or volcanic eruption. These aren't random, he said, tracing the arc of activity from New Zealand to Alaska. They're the boundaries where tectonic plates collide, grind, or pull apart, just like they did during Pangaea's breakup. His colleague, Dr. Amina Okoye, pointed to a cluster of dots along the mid-Atlantic ridge. And here, where the plates diverge, we see the same process that split Africa and South America. Magma rises, cools, and forms new crust, pushing the continents apart inch by inch. The evidence was undeniable. In Nepal, where the Indian plate crashes into Eurasia, the Himalayas grow taller by a centimeter each year. The same collision once built the Appalachians during Pangaea's formation. In Iceland, geysers and fissures reveal the raw power of the mid-Atlantic ridge, a living snapshot of the rifts that shattered the supercontinent. Even earthquakes tell the story. The 2004 Sumatra quake. Samuel pulled up a simulation of the devastating tsunami. The Indian plate subducted beneath Burma, just like the oceanic plates that once vanished under Pangaea's edges. Amina nodded. And look at California. She tapped the San Andreas Fault, where the Pacific and North American plates slide past each other. This strike-slip motion mirrors the shearing forces that helped break Pangaea's crust. Volcanoes, too, are part of the legacy. From Hawaii's hotspot-driven islands to the explosive eruptions of Mount St. Helens, Earth's fiery breath reminds us that the mantle is never still. The same mantle plumes that fueled the Siberian traps and the Great Dying still simmer beneath our feet. The planet is alive, Samuel murmured. Pangaea's story didn't end, it just outside. The ground beneath them hummed with unseen energy. The same force that once united, then divided, a world, and somewhere, deep in the mantle, the Earth was already dreaming of its next supercontinent. The end of the dinosaurs was the dawn of a new world. When the asteroid struck, it didn't just erase the giants, it cleared the stage for the survivors. Mammals, small and unassuming, had scurried in the shadows of Tyrannosaurus and Triceratops for over 150 million years. Their time had finally come. In the aftermath of the impact winter, the rules of survival changed. Size was no longer an advantage, agility and adaptability were. The mammals, with their fast metabolisms, insulating fur and versatile diets, thrived where the dinosaurs had faltered. They burrowed into the earth, foraged in the twilight, and multiplied in the absence of reptilian predators. Dr. Eleanor Voss knelt beside a fossilized burrow in Montana, her brush revealing the delicate bones of a Purgatorius, one of the earliest primates. This little creature, she murmured, lived through the worst disaster in Earth's history. Its descendants would inherit the planet. The dinosaurs' extinction had been a gift, one written in fire and darkness. Without their dominance, mammals diversified explosively. Within 10 million years, they had evolved into forms as varied as bats, whales, and early horses. The forests, once ruled by theropods, now rustled with the movements of nimble, warm-blooded hunters. The oceans, emptied of mosasaurs, welcomed the ancestors of dolphins and seals. But the dinosaurs' legacy wasn't entirely gone. High in the trees, the last theropods, birds, flourished. Their feathers, once for display or insulation, now carried them through the skies. They sang where their ancestors had roared, their melodies a faint echo of a lost world. And then, 66 million years after the asteroid, one particular mammal, Homo sapiens, dug up the bones of the fallen giants and marveled at their might. The dinosaurs had ruled, the mammals had inherited, and the cycle of life, unbroken since Pangaea, continued. The Earth does not stand still. From the moment of its violent birth to the slow drift of continents today, our planet has been a canvas of constant change. Pangaea, that ancient supercontinent, was not the beginning, nor was it the end. It was a single fleeting moment in a story that spans billions of years, written in stone and sealed in time. The evidence is all around us. In the jagged peaks of the Himalayas where India collides with Eurasia, we see the same forces that once forged Pangaea's mountains. In the restless rifts of East Africa, where the land tears itself apart, we witness the infancy of a new ocean, just as the Atlantic was born from Pangaea's rupture. Even the air we breathe, the soil beneath our feet, is shaped by the slow, unyielding dance of geology and life. Dr. Elias Carter stood on a windswept cliff in Newfoundland, where ancient seafloor had been thrust upward to form a stark, grey plateau. Beneath his boots, fossils of trilobites and Homelonotus, creatures that had lived and died long before Pangaea, were embedded in the rock like forgotten letters. He ran a hand over the stone, feeling the ridges of time. "People think of continents as permanent," he said to the students gathered behind him. "But the Earth doesn't care for permanence. It reshapes itself over and over, with or without us." A gust of wind carried the scent of salt and iron from the waves below. Somewhere in those depths the mantle still churned, its currents tugging at the plates above. The Atlantic, which had begun as a crack in Pangaea's skin, now widened year by year. One day, it too would close, swallowed by the same forces that had birthed it. And what then? The cycle would continue. Pangaea, the next supercontinent, might rise from the collision of the Americas and Eurasia. Its mountains would tower over deserts vaster than the Sahara. Its oceans would churn in unfamiliar basins, and life, whatever life endured, would adapt as it always had. But Pangaea's legacy would remain in the fossilized bones of Lystrosaurus, scattered from Antarctica to India, in the coal beds of Pennsylvania and Poland, remnants of a single sprawling forest, in the DNA of lemurs and lungfish, marsupials and magnolias, all bearing the fingerprints of a world long gone. The Earth remembers, and it is not done yet. As the sun dipped toward the horizon, painting the cliffs in gold and crimson, Dr. Carter turned to his students. "We are temporary," he said. "Our cities, our civilizations, they're just whispers in geologic time. The continents will keep moving. The oceans will keep growing. The story doesn't end with us." He picked up a fragment of shale, its surface etched with the delicate imprint of a fern that had lived and died 300 million years ago. "The Earth's story is unfinished. And the next chapter," he tossed the fossil into the wind, watching it vanish into the sea below, "will be written long after we're gone." The waves crashed against the rocks, relentless as time itself, and the world, ever changing, moved on. The Earth was restless. Beneath our feet, the tectonic plates continued their slow, inexorable dance. The same forces that had forged and shattered Pangaea, now shaping the next great supercontinent. Scientists called it Pangaea, a landmass that would one day unite the scattered continents in a new embrace. Dr. Eleanor Voss adjusted the holographic projection in her lab, watching as the simulation accelerated through millions of years in seconds. North and South America drifted westward, their coastlines crumpling against Eurasia in a slow-motion collision. Africa, already pressing into Europe, fused with the landmass, sealing the Mediterranean Sea forever. Australia, creeping northward, nestled against Southeast Asia, while Antarctica, perhaps freed from its icy prison by shifting currents, joined the southern flank. The result was a vast, sea-shaped continent encircling what remained of the Indian Ocean. "It won't be like Pangaea," Dr. Voss explained to her students. "Pangaea was a near-perfect union of all land masses. Pangaea will form differently, through the closure of the Arctic Ocean, pulling continents together over the North Pole." The implications were staggering. Pangaea's geography would reshape the planet's climate, its ecosystems, its very life. With most land clustered in the northern hemisphere, the supercontinent's interior would become a sprawling desert, its heart starved of moisture by the sheer distance from any ocean. The poles, now dominated by open water, might freeze into even vaster ice caps, reflecting sunlight and cooling the planet further. And the coasts? "Imagine monsoons," Dr. Voss said, zooming in on the simulation's eastern edge. With a single massive ocean battering Pangaea's shores, rainfall along the fringes would be biblical. hurricanes the size of continents, flooding that makes today's storms look like drizzle. The students exchanged uneasy glances. One raised a hand. Would anything survive that? Dr. Voss smiled faintly. Life always finds a way, but it won't be life as we know it. The hologram shifted, populating Amasia with speculative flora and fauna. In the deserts, creatures with thick, water-retaining hides lumbered between towering cacti analogues. Along the storm-lashed coasts, amphibious mammals with webbed paws hunted in brackish deltas. And in the temperate highlands, what was left of the Rocky Mountains after eons of erosion, feathered descendants of birds scurried through fern-choked valleys. Evolution thrives on isolation, Dr. Voss continued, but supercontinents force connection. Species that evolved apart for millions of years will suddenly collide. Predators will meet prey with no shared history. It'll be chaos and innovation. The simulation sped up again, showing Amasia's eventual fate. Just as Pangaea had fractured, so too would this new supercontinent. Rifts tore through the land, new oceans yawned open, and the cycle began anew. The students sat in silence, staring at the flickering hologram. One finally spoke. "How long do we have?" Dr. Voss chuckled. "About 250 million years, give or take." Outside the lab window, the sun shone on a world that seemed eternal. Green forests, blue oceans, cities humming with life, but the ground beneath them was moving, always moving. Pangaea had been, Amasia would be, and the earth, ever-changing, would write its next chapter in fire and stone. The earth remembers. In the quiet of a desert canyon where the wind hums through layers of sandstone, time folds in on itself. The rocks here, red, gold, and ochre, are pages in a story older than bones, older than trees, older than the first breath of life. They whisper of oceans that rose and fell, of mountains that grew skyward only to crumble into dust, of continents that danced together and apart in a rhythm as old as the planet itself. Pangaea was not the first supercontinent. Long before Gondwana and Laurasia collided, before the Appalachian peaks clawed at the sky, there was Rodinia, a colossal landmass that ruled the world 1 billion years ago. And before that, Kenoland. And before that, Ur. Each rose from the chaos of plate tectonics, held dominion for an age, then fractured like ice on a warming lake. The cycle is eternal. Dr. Elias Carter knelt in the shadow of a towering cliff in Arizona, his fingers brushing a seam of shale. Embedded within it were ripple marks, frozen echoes of waves that had lapped at a vanished shore. "This was a beach," he murmured. "Once, before this desert was a desert, before these rocks were stone." His students gathered close, their boots scuffing the dust of an ancient seabed. One, a young geologist named Mira, crouched beside him. "How long ago?" 300 million years, when Pangaea was young. The wind gusted, carrying grains of sand that had once been part of mountains, part of shells, part of bones. The earth does not waste, it recycles. In the grand tapestry of geology, Pangaea was but a single thread, a magnificent, fleeting stitch in time. Its birth had been written in fire, its death in the slow patience of water. And when Amasia rises, when the continents merge once more, it will be another verse in the same endless song. Life, too, dances to this rhythm. The dinosaurs, those magnificent rulers of a united world, had their moment. Then the asteroid came, the curtain fell, and the mammals took the stage. Now, our cities sprawl across the fragments of Pangaea, our roads tracing valleys carved by rivers that flowed when the supercontinent was whole. We are fleeting, the earth is not. As the sun dipped below the canyon rim, painting the rocks in hues of blood and gold, Dr. Carter stood. He placed a hand on the cliff face, feeling the pulse of deep time beneath his palm. "Pangaea is gone," he said, "but the dance goes on." Above them a hawk circled, a tiny, feathered descendant of theropods that once ruled this land. Below, the Colorado River carved its path, as water has always done, as it will always do. The continents will collide again, the mountains will rise, the oceans will swallow and spit out new shores, and the earth, ever changing, ever ancient, will continue its slow, beautiful waltz through time. The cycle is unbroken. The cycle is eternal, and we all of us are just passing through.